In this session on this topic, concepts are going to be clear of all these through illustrations. Being very important, it is requested go through the session completely. Now let's start the question. Question is, a polythene piece rubbed with wool is found to have a negative charge of 3 × 10⁻⁷ Coulomb. Estimate the number of electron transfer from which to which. Second, is there a mass transfer of mass from wool to polythene? Right? This question is very simple to clear the properties of the charge. Right? This is applicable for all 12th standard, JEE Main, NEET, and CUET, etc., etc. Basic properties, concept, application, solution. Basic properties: charge is scalar quantity. Charge can be added or subtracted vectorially or algebraically. Can be added algebraically. Algebraically, simple plus minus, right? Charge is always, charge exists without mass. Charge cannot exist without mass. Cannot exist without mass. Though mass mass can exist without mass. Third, additive nature of electric charge. Additive charge is a property due to which total charge system is obtained by algebraic sum of all the charges present anywhere on the system. Right? Next, if the size of charge bodies are very small as compared to the distance between them, they can be considered as a continuous distribution charge or point charge. That can be considered as a point charge. Conservation of energy. Conservation of electric charge. Charge can neither be created nor be destroyed. In physical process, charge may be transferred from one part of the another part of the system, but the net charge always remains same. Next, quantization of charge. So, the charge on any body can be expressed as an integral multiple of basic unit of charge. That is charge on one electron. This phenomenon is called quantization of charge. Next, Q equal to N into E. E is the electronic charge. That's value is 1.6 × 10⁻⁹ Coulomb. Coulomb is the SI unit of charge. N is the integral multiple 1, 2, 3, 4, anything. Right? Now, next, let's start the cause of quantization. What is the cause of quantization? Quantization charge occurs because one body is rubbed with another body. Only integral multiple of electrons, integral number of electron is transferred. That is the cause of quantization. Now let's start the question. Question is Q equal to NE. This is according to. Now according to the question given is, how much charge is given? 3 × 10⁻⁷. Q equal to 3 × 10⁻⁷ Coulomb. Q equal to E, we know 1.6 × 10⁻⁹ Coulomb. Right? We have to find the number of electrons. Right? On substituting 3 × 10⁻⁷ equal to N into 1.6 × 10⁻⁹. On simplification, N comes up to 1.875 into 10⁹ right? Number of electrons transferred. Of course, what is the question? Polythene piece rubbed with a wool is found to have a negative charge. For polythene piece rubbed with wool is found to have a negative charge. Charge on polyethylene is negative. Charge on polyethylene is negative. Means from wool to polyethylene. Electrons will be transferred. Electrons will be transferred from wool to polyethylene. Second part is there any transfer of mass from wool to polyethylene? Now in this, I have discussed the property charge cannot exist without mass. Yes, there will be also mass transfer, but very negligible, because mass of electron is 9.1 10 to the minus 31 kg, right? Now next, Coulomb's law. I will discuss the Coulomb's law. Now topic will be Coulomb's law. Question is, for point charges QA 2 microcoulomb, QB minus 5 microcoulomb, QC QD minus 5 are located at the corner of the square ABCD of side 10 centimeter. What is the force on charge of 1 microcoulomb placed at the center of the square? Right? Now, let's start the concept applicability first. What is Coulomb's law? According to Coulomb's law, the force of interaction that may be attractive or that may be repulsive depending on the charge. If the charges are like charges, repulsion will be there. If the charges are unlike charges, there will be attraction. Like means both are same nature. Unlike means both are of opposite nature. That will be proportional to product of the charges. Product of charges. And it will be proportional to the distance between them. Distance between them. Mathematically, F equal to 1 over 4 pi epsilon naught product Q1 Q2 upon R square. Say this is charge Q1, this is charge Q2, distance between them is R, right? Value 1 over 4 pi epsilon naught is 9 to 10 to our 9 SI unit, right? Epsilon naught is at 8.85 10 to minus 12, and it's called permittivity of the free space. Its dimensions are m की power minus 1, l की power minus 3, t की power 4, a square, right? Coulomb's force acts along the straight line connecting the points of location of charges. It is central and spherically symmetric. What is definition of 1 Coulomb? 1 Coulomb में क्या करना होगा? 1 Coulomb is a charge which when placed at a distance of 1 meter from another charge of same magnitude in vacuum experience an electric force of repulsion of magnitude 9 10 to the 9. Right? 1 Coulomb of charge is defined as like this. Regarding Coulomb's law, Coulomb's law of interaction, Coulomb's law of interaction in two body interaction, it is not affected by presence of the other charges or absence of the other charges. I think both. Presence or absence of other charges. Coulomb's law is holds of only stationary charges or moving charges. Only for holds good only for, in this case, only point charges. Point charges, right? Regarding absolute permittivity. Relative permittive medium is defined as the ratio of dielectric force between the two, you know, F air 1 over 4 pi epsilon naught Q1 Q2 upon R square, this is equation 1, and F medium 1 over 4 pi epsilon naught into K Q1 Q2 upon R square. This is equation 2. In that case, if we divide these two, we get K. That is the relative permittivity of them. This is the ratio of two forces. Relative permittivity of medium is defined as the ratio of electric force between the two charges separated by a certain distance in vacuum to the electricity force between the same two charges separated by the same distance in that medium. Right? That is known as relative permittivity. Next, Coulomb's law in vector form. Coulomb's law agree with the Newton's third law. Newton's third law. Newton's third law. Comparison of Coulomb's law with gravitational force. Both Coulomb's and Newton's force follow inverse square law. That is inversely proportional to 1 over. You know Newton's law of gravitational force is F equal to capital G universal gravity M1 M2 upon R squared. Attractive always. Newton's law of gravitational force is always attractive. And whereas Coulomb's force may be attractive or repulsive depending on the nature of the charges, whether they are like or whether they are unlike. Electric force is much stronger than the gravitational force. Fe, I think, check Fg, right? 39. If charge Q is divided into two parts, Q1 and Q2, means Q equal to Q1 plus Q2, the repulsive force will be maximum when both are equal, when Q1 equal to Q2, right? Next. Next, I will start the question. The square is there. A, B, C, D. If you join them, you join them. This is right. The square of side 10 centimeter. This is at point P. Charges are minus 2 and 5. 2 and minus 5. 2 microcoulomb minus 5 microcoulomb. 2 microcoulomb minus 5 microcoulomb. At point P, it is 1 microcoulomb. Now, we have to find four charges. FPA, FPB, FPC, FPD. Again, everything 1 over 4 pi epsilon naught. Product of the charges. 5 FPA, that is 2 into 1. 2 into 1 into 10 to the power minus 6 into 10 to the power minus 6 divided by R square. That is PA square. Right? What will its nature? Its nature will be PA. Both are of same nature. Force will be repulsive. It will be, force on this will be along AP produce. Along AP produce. Along AP produce. It will be in this direction. FPB, FPC निकाल लीजिए पहले 1 over 4 pi epsilon naught 2 into 10 to the power minus 6 into 10 to the power minus 6 upon P C square. In this case, this will be opposite nature. So the same nature, repulsive along CP produce. Along CP produce. Means these two forces are equal in magnitude but opposite in nature. As PA equal to PB equal to PC equal to PD equal to by geometry. ठीक है? In that case, both are acting in the opposite direction. Therefore, FPA and FPC are equal in magnitude and opposite in direction. Opposite in direction. Therefore, will cancel out. And similarly, FPB will be equal to FPD. It will be PB. This will be attractive in nature. It will be attractive in nature means this will go PB produce along PB. FPB will be along PB along PB and FPD will be along PD, attractive in nature, PD along PD. Both are along PD. Both are opposite in nature, equal in magnitude, right? Therefore, also cancel out. Therefore, net force at point P will be equal to 0. If the 0 cancel out, then simple net force on this, apply the law of parallelogram forces, then resultant will be the final answer. Right now, I will start the question on algebraic sum of charges. Now, the question is on distribution of charge on identical bodies. This question has been taken from JEE Main 2003, applicable for NEET, JEE Main, etc. Two identical conducting spheres. One is P, one is S. Charge on this is Q, charge on this is Q. Repel each other with a force is 16 Newton, repulsive force. Right? Separated by distance, say R. Right? Now, a third charge S, identical in shape, S. So what will happen? इस पे 0 charge है initially, इस पे Q charge है, equally distribute हो जाएगा. Charge on P will become Q by 2. And charge on this is S, this is P, this is R, this is R, this is R. Right? In that case, R is come into contact with this. This is Q by 2, this is Q. Q plus Q by 2, that is 3Q by 2, will be shared equally as identical. This pentagon as identical. The sphere is there. Therefore, 3Q by 4. So charge on S will become, this is P Q by 2, this is S 3Q by 4. We have to find the force separated by the same distance R. Now, from the given information, initially F will be equal to 1 over 4 pi epsilon naught Q into Q upon R square. That is equal to 10 Newton. This is equation 1. 1 over 4 pi epsilon naught, right? In second case, F dash will be equal to 1 over 4 pi epsilon naught Q by 2 into 3Q by 4 upon R square. That is comes out to be 1 over 4 pi epsilon naught 3Q square, Q square by R square into 3/8 from equation 1. From equation 1, we get 16 into 3/8, that is to 6 Newton. Yani ki force of repulsion will be there and that will be 6 Newton. That is the D option. Now I will repeat it again. Option D is correct. D option is correct. In this case, sharing of charges was there. Initially, charge Q, another identical नहीं हो तो another ratio में double. In this case, identical, in which case it will be equally shared. Now, this is P and this is R. So, P, Q plus 0, Q equally shared divided by 2. Q by 2 is पे आएगा, Q by 2 is पे आएगा. Now, this is, bring it here. This is Q, this is Q by 2. Q plus Q by 2, 3Q by 2. Equally shared, half कर दिया. Half करने के बाद, फिर इसके बीच force. Keeping the distance same, we have to find the new force acting between them. Simplify, we get the answer 6 Newton. D option is the correct, right? In this session, till now we have gone through these. If you have any doubt, please comment. Further, we are going to discuss these concepts will be clear through illustration. Going to be very important. It is requested go through the session completely. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर आपने YouTube चैनल से सब्सक्राइब नहीं किया, please subscribe it and share with your colleagues and friends. Now let's start with the question and concept. Concept applicable in the solution. Electric field intensity at any point due to source charge is defined as the force experienced by unit positive charge or negative charge. That is the positive charge. What is the essential condition? Charge placed at that point without disturbance. No disturbance should be there of the source charge. Mathematically, E equal to F by Q. It is a scalar quantity or vector quantity. It is a vector quantity. This dimension, you know E equal to F by 2. MLT minus 2 divided by AT. Charge की dimension AT. So M L T minus 3 A minus 1. Direction is positive to negative, or you can say away from positive charge towards negative charge, right? Next, electric field due to point charge is given by E equal to 1 over 4 pi epsilon naught Q upon R square. Electric field due to point charge. Electric field at any point in space due to charge depends only on the distance. That means the magnitude activity due to point charge is same at all points of a sphere. Therefore, it has a spherical symmetry. Electric field due to point charge have a spherical symmetry, right? Let's start the question. Question is 6 microcoulomb. One string is there, one is the 6 microcoulomb. This is weight mg plus 6 microcoulomb plus 6 microcoulomb and electric field is acting downward. Electric field is acting downward. Then, what will be the tension in the string? Tension, you know, this is the string tension, it is the weight, and force due to electric field will be Q into E. According to free body diagram, the resisting tension will be net downward force will be equal to the upward force. Downward force equal to upward force. No, downward force means weight is acting plus electric force due to electric field. QE equal to tension. In this case, Mass is given, acceleration due to gravity is known, charge is known, electric field is known. Electric field is given in this case is 400 Newton, electric field 400 Newton per Coulomb. So substituting all the values, we will get the answer. Tension will be equal to 1.22 into 10 to the power minus 2 Newton. Right. This was the case 1. This was the case 1. Case 2. Case 2 will be when charge is replaced by minus 6 microcoulomb. Then the electric force due to this will be like this. In that case, mg equal to T plus QE. T will be equal to mg minus QE. Substituting the values. On substituting the values, we will get the answer 74 into 10 to the power minus 4 Newton. I think this is clear. Now, next, what are electric field lines? Electric field line is a curve in such a way that tangent to it at any point in each is in the direction of electric field at that point. Electric field line in space, it is a curve in 3 dimensions, right? Electric field density of lines is more near the charge, and away from the charge the field is weak, so density of field lines is less, right? Now, property of electric field lines. Direction of electric field lines is away from positive, radially outward. Like next, property of electric lines. Electric field lines start from positive charge, and terminate at negative charge. That's terminate. In case of single charge, this may start or end at infinity. Third, tangent at any point on electric field line shows the direction of electric field at that point, right? Next, two electric field lines never intersect each other because if they intersect, then two tangents drawn at that point will represent two directions at that point, which is not possible. Next, in a charge-free region, electric field lines can be taken to be continuous with curve without any breaks. Electric field lines are perpendicular to surface of charge conductor. Electric field lines contract lengthwise to represent attraction between the two unlike charges. Electric field exert pressure sideways pressure to represent. These are the 7 properties I have discussed. Again repeating, electric field lines start from positive and terminate at negative. Direction of tangent and would give the direction of electric field. Two electric field never intersect. If it intersects, two directions will, which is not possible. Electric field lines can be taken to continuous curve without any breaks. Electric field lines are perpendicular to the surface of the charge conductor. Electric field lines contact lengthwise to represent attraction between the two unlike charges. Electric field lines exert sidewise pressure to represent repulsion between the two like charges. Now, representation of electric line fields. Electric field lines always point away from the positive charge and towards the negative, as already discussed. In fact, electric originate at a positive charge and terminate at a negative charge. This is for uniform field, this is for non-uniform magnetic electric field, right? Now, this is direction from positive charge, radially outward. This is radially inward. The electric field lines start from positive charge and end at the negative charge. In this case, you say, in this case, Q1 charges are same. Q1 equal to Q2 positive charge. In this case, Q2 is greater than Q1. So in this case, it is denser. In this case, equal density is there. In this case, you can observe the difference of densities, right? Next, conductors in electrostatic field. Electric field light do not pass through the conductor, hence the interior of the conductor is free from the influence of the electric field. In this, electric field is equal to 0. Total charge of charge conductor lies at its outer surface of the conductor. The magnitude of field strength at any point on the surface of conductor is proportional to the surface charge density. Surface charge density at that point. This is all about this thing. Now, next chapter, I will discuss the dipole, regarding the dipole. Let's start the dipole. Now, the topic is electric dipole. Question is, what is the magnitude of electric field intensity due to dipole of moment 2 into 10 to the minus 8 Coulomb meter at a point distance 1 meter from the center of dipole, when the line joining the point of the center of dipole makes angle 60 degree with the dipole axis. This question is applicable for 12th standard, JEE Main, NEET, CUET, and other entrance examinations. Before the solution of this question, I will discuss a certain concept applicable. First of all, electric field intensity to dipole at any point. I am going to discuss, suppose this point is A, this point is B, minus Q plus Q. What is the axle line? Axle line joining these two. Suppose we find the electric field intensity at this point. E axle will be 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught, 2 PR upon R square minus A square to the power 4 square. Right? Now, and in case of approximation, 1 over 4 pi epsilon naught, 2 p upon R cube along. In this case, this is the point BP produce. That is same in the direction of dipole. What is the dipole? Dipole is P equal to any charge into separation, and direction is from negative to positive, right? Direction is negative to. It is same in the direction of dipole. Electric field due to dipole at equatorial point. Equatorial point is, suppose the center of this, we take this perpendicular bisector, and this point would be, this is the point P. In that case, electric field intensity due to this, away from positive charge towards negative charge. On resolution, we will get along this direction. In the equatorial is 1 over 4 pi epsilon naught P upon R square plus A square की power 3 by P along. This is anti-parallel to this, along BA, parallel to BA. This is in anti-parallel to dipole moment direction. What is the relation? E axial is equal to magnitude wise to equatorial, right? E axial equal to twice equatorial. Now, at any point it is given by E equal to 1 over 4 pi epsilon naught P under root 3 cos square theta plus 1 divided by R cube. R cube, right? Next. Now in this question, and direction of theta, tan of alpha is equal to 1 by 2 tan of theta. These are the two at any point. Now let's start the question. What is the question? Question is, what is the magnitude active in dipole? Dipole moment P is given, 2 into 10 minus 8 Coulomb, distance given, angle given. Means theta is given 60 degree. P is given 2 into 10 to the minus 8 Coulomb meter. And R is given to you, distance 1 meter. Right? Just substitute the values. On substituting, we get electric field density on simplification 238.1 Newton per Coulomb. Electric field density 238.1 meter per Coulomb. Now I think EXL is this one, E equator is this one, relation is this one, and at any point is this one, right? I think all directions I have discussed very well. In case of equatorial, anti-parallel to dipole moment. In case of XLN, parallel to dipole direction. And in case angle, tan alpha equal to half of angle tan of theta. Next, I will be going to discuss Gauss's theorem. Electric field, dipole in a electric field. An electric dipole of the moment, this is aligned to uniform electric field. This, yani, P is given to you. This is P, this is E. Calculate the potential to hold the dipole at 60 degree with the direction of electric field. Let's start. We know dipole and electric. One is torque. Torque is P cross E. Cross product of this. That is PE sin theta into unit vector in the direction of this. So direction of torque will be, suppose one is P, one is E. PE, this is theta, this will be 90 degree, this will be 90 degree. Perpendicular to both the directions because cross product. Answer is AB sin theta into unit vector perpendicular to both the vectors. So this is P cross E, right? And next, work done in dipole. Work done PE potential energy equal to minus PE cos theta 2 minus cos theta 1. Cos theta 2. In this case, theta 2 is given to you 60 degree, theta 1 is given to you 0 degree. Moment is given to you, that is 5 into 10 to the minus 8, and electric field is given to Coulomb meter, and that is given to 1.44 into 10 to the power 4 Newton per Coulomb. In that case, now formula is available with us. P is known, E is known, cos theta cos 60 minus cos 0, that is PE. P की value put करो, E की value put करो, that is electric field. That comes out to be potential energy or work done. That comes out to be simplification 3.6. You can solve it into 10 to the power minus 4 joule. In this case, most important thing is to how to identify theta 1 and theta 2. That is the only basic in this question. Initially, angle is theta 1. Hold dipole to hold at 60 degree with the direction of electric field. Initial theta 1 0 degree, theta 2 60 degrees. Solve it. Next, Gauss's theorem. Gauss's theorem. Question is 5 charges plus Q, 5Q plus 3Q minus 2 minus Q are situated as shown in the figure. The electric flux due to this configuration through S is. Question is taken from JEE Main 2024 and applicable for all these. Before we start with the question, let's discuss certain concept applicable. Gauss's theorem. The surface integral of electric field intensity over any closed surface, that is known as Gauss's theorem, in free space is equal to 1 over epsilon naught times the net charge enclosed within the surface. Net charge. This is the Q is net charge inside the surface. The net charge inside the surface. Let's see. Let's start the question. In this case, we have to find the electric flux. Electric flux phi E equal to one is E dot ds or 1 over epsilon naught Q net inside the surface. Q net will be equal to Q net is inside 5 plus 6 minus 4. 5Q 1 over epsilon naught 5Q plus Q minus 2Q. That is 4Q upon epsilon naught. This is the answer. This was the application of Gauss's theorem. How to consider the charge. D is the correct option. D is correct option. D is correct option. Next question is, an electric flux is given by 6I plus 5J plus 3K unit. The electric flux through a surface area is 39 meter per second lying in YZ plane. We know electric flux is dot product of also E dot ds. E dot ds, right? Now, it is given to you E 6I plus 5J plus 3K dot 30I. You know, area vector is always perpendicular to the surface. In this case, lying in the YZ plane. YZ plane is that is in the along axis, that is perpendicular to that, right? On we know I dot I equal to 1, I dot j 0, I dot k 0. Simple property. On simplification, we get 360 plus 0 plus 0. That comes out to be 360. What will be the unit? What will be the unit? Electric field unit and that unit. That is C option is the correct. Electric field unit Newton per Coulomb into meter square. 360. Option C is correct. Now, I am going to discuss the application of Gauss's theorem. Application of Gauss's. Now, application of Gauss's theorem, and before discussing this, electrostatic force due to continuous charge distribution. What is continuous distribution of charge? The region in which charges are closely spaced is said to be continuous distribution of charge. It is of the following type. Linear charge, it is represented by lambda. Linear charge density is defined as the charge per length of linear charge distribution. In this case, force is given by 1 over 4 pi epsilon naught, that is lambda dl upon r naught square r naught cap. Right? Lambda is the linear. Surface charge density. Surface charge density in this will be surface area. It is two dimensional. It is noted by sigma. It is noted by sigma. In this case, force will be equal to 1 over 4 pi epsilon naught S sigma ds upon r naught square r naught cap. Volume distribution charge, it is denoted by rho. Volume charge density is defined as the charge per unit volume charge distribution. In this case, force is given by 1 over 4 pi epsilon naught volume rho dV upon R naught square R naught cap. This is all about the continuous distribution of charge. That is the linear one, surface one, volume one. Linear, lambda, surface, sigma, volume, rho. Right? Now, application of Gauss's theorem. Application of Gauss's theorem. Electric field due to some metric charges configuration using Gauss's law. Electric field due to infinitely long thin straight charge wire is given by electric field is given by 1 over 4 pi epsilon naught twice lambda by r. Twice lambda by r. All derivations are important. You can go through it. Right? Now, this is the end result. In this case, this is the Gaussian surface. Electric field is on account of this, on account of this, electric field is 0, on account of this, for curved surface, electric field is considered, that is 2 pi r. From this, you have considered the electric field, right? Next, variation of electric field is, as it is inversely, as E inversely proportional to R. It is known as rectangular hyperbola. This is rectangular hyperbola. It decreases like this. If lambda is greater than 0, the direction of electric field at every point is radially outward. If it is less than, that is inward. Right? Next, field due to thin, infinite plane sheet of charge. In this case, E comes out to be sigma over epsilon naught. E comes out to be sigma over epsilon naught. And if the infinite plane sheet of charge has a uniform thickness, E upon 2 epsilon naught. In this case, E comes out to sigma over epsilon naught. E is independent of R, the distance of the point from plane charge sheet, right? Now, simple formula in this to derive it, take the left hand side of the Gauss's theorem E dot ds and equal to 1 over epsilon goes. Electric fluid to infinite. There are 3 regions. Region 3, that will be equal to 1 over 2 epsilon naught sigma 1 over sigma 2. In this case, minus 1 over 2 epsilon naught sigma 1 plus sigma 2. In this case, 1 over 2 epsilon naught sigma 1 minus sigma 2, considering this is greater than this. Next, electric field due to non-conducting charge solid sphere. In this case, these are the formulas applicable in this case. E inside is rho r upon 3 epsilon. E on the surface, put r equal to radius of that is rho r upon 3 epsilon. And outside, जो actual formula होता है उसको लगा दीजिए, जो formula लगेगा that. Right? What is the graph? As we say, inside E is directly proportional to R. So this is straight line. This is the straight line. Maximum is at the surface and then decreases like this. Right? This is all about the field. I have just only discussing the formulas which are applicable for this. Derivation may be carried out or will be discussed in another session. Right? Field due to uniformly charged thin spherical cell. Thin spherical, that's sigma. This is the uniform surface charge that is thin spherical cell radius r. The Gaussian surface is spherical. Then outside outside will be E equal to 1 over 4 pi epsilon naught Q upon R square. Inside on the surface E equal to sigma over epsilon naught. And at a point inside the 0, that will be equal to 0. Right? This is all about this thing. A variation is given to inside it is 0, maximum surface, then it start decreasing. I have discussed the 5 cases. I will discuss the 5 cases here. Right? In this session up to now, we have gone through all these. Efforts are made to clear the concept through illustration. If you have any doubt, please comment. In this session, further we are going to discuss these. Concept will be cleared through illustrations. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर आपने YouTube चैनल सेट शिफ्ट सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद colleagues and friends. Now let's start with the question and let's start the question. Two particles A and B having charges 20 microcoulomb minus 5 respectively had fixed with a separation of 5 centimeter. At what position third charge particle is placed so that it does not experience the net electric force, right? Net electric force. In this case, this is A, this is B. This is 20 microcoulomb. This is minus 5 microcoulomb. Separated by distance 5 centimeter. Right? We have to place a third charge where null point will be reflected. Null point means force acting on that is equal and opposite in nature, right? Now, before starting this question, I will discuss certain things. Say, this is Q1, Q2. This is A, this is B, separated by distance D. Now, nature of charges, both positive. Third charge is placed here. Third charge is placed here, point P. Then this is plus Q. Repulsive, repulsive. If negative, then both positive, both negative, and then this is positive. Attractive, attractive. Both are in the same direction, both are in the same direction. Similarly, when both are negative, this is positive, when it is negative, it same will be the case, right? Just change. Means null point will not be received. Null point will not be outside when two charges are like in nature, right? Now, say one is positive, one is negative. This is A, this is B, separated by distance D, Q1, Q2. This is negative, this is positive, right? In this case, see point P. This point is P. Now, at a distance X. This is positive, this is negative. We put here charge, positive charge, suppose, plus Q. This will be repulsive, this will be attractive. Both are in opposite direction. Yes. Null point will be outside. In this case, if we take here charge Q, say positive. For this it will be repulsive, for this it will be repulsive. So null point will be inside. Null point will be inside. So conclusion is, for like charges, null point will be outside. Null point will be outside, and for unlike charges, for like charge null point will be inside, and for unlike charges null point will be outside, right? Now we go to the question again. Then this is P having charge Q. This is Q1, this is Q1, this is Q2, right? In that case, you see, For this, PAB will be, say this is positive, repulsive, this is attractive. Null point will be. In that case now, 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught, 20 into 10 to the minus 6 into Q upon 5 plus x whole square equal to 1 over 4 pi epsilon naught 5 into 10 to the minus 6 into Q upon x square. These are the sense of x. This is sense is say x from here, right? In that case, this goes, this goes, this goes, this goes, this goes, this goes. Simply is 4. 4 upon 5 plus x whole square equal to 1 over x square. That is 5 plus x equal to plus minus 2x, considering positive sign. 5 plus x equal to 2x. X comes out to be 5. X comes out to be 5, considering negative sign. Then 5 plus x equal to minus 2x, minus 3x equal to 5, x equal to minus 5 is 3. Means your negative side disconnected. Because these are the unlike charges, null point will be outside, right? And at a distance of 5 centimeter towards the negative, right? Now, answer will be at what point? At 5 centimeter from minus on the right hand side. This is the answer. A is the answer. Now it's a shortcut. We can give the directly answer also. Null point will be x equal to d upon under root q2 upon q1 plus minus 1. Right? Here q1 is greater than q2. q2 is greater than q1 magnitude wise. Magnitude wise. Right? Negative is for outside and positive for inside. Negative for inside. Now you see it directly. The final answer will be this will be Q2, this will be Q1, right? So D 5 upon under root Q2 20 divided by 5 plus minus 1. This is x. X equal to 5 upon, this will be 4. 4 divided by 2. This will be 4, 2. 2 plus minus 1. Plus minus 1. In this case, outside will reduce the 2 plus 2 minus 1, that is 5 centimeter. 5 centimeter from the right hand side. So, answer will be when like charges, null point will be outside and outside towards the charge smaller in magnitude, that it is positive or negative, and you follow this formula, right? This is very, this answer can be given orally, but before giving the answer orally, I will explain the complete concept right now. Next question. Question is, two identical charged spheres are suspended by a string of equal length. The strings make an angle theta with each other when suspended in water. The angle remains the same. If the density of matter of the sphere is 1.5, Dielectric constant will be, we have to fill in the blanks. Question is taken from JEE Main 2024. Its answer to this question can be given orally, right? Orally when the question is direct one. But before giving the answer question, I will develop that formula which is applicable directly. In case of slight twisting, that formula will be failed. Therefore, I will request go through the complete question. Then finally, I will write the direct formula here. Right? Let's start. Lamis theorem. In this case, applicable is Lamis theorem. O A B, these are the two charges, identical charges. Say this is Q, this is Q. Electrostatic repulsive force. Weight is acting vertically downward. Weight is acting tension in the stem. Lami's theorem is applicable when three concurrent forces concurrent means acting at a point. Three concurrent are in equilibrium. Three concurrent forces are in equilibrium, right? Then Lami's theorem is applicable. In this case, this is weight W, this is tension T. This complete angle is theta. So this will be theta by 2. So length is L. This length is L, this length is L. Right? And this point is M. This point is M. Now, Lami's theorem is in terms of angle also. So this is point O, P, Q, R, alpha, beta, gamma. P upon sin alpha, Q upon sin beta, R upon sin gamma. This is in terms of angle, or in terms of size I am giving here, right? Now, according to Lami's theorem, these two forces are in equilibrium. Then weight W. W upon corresponding sides. This will be like this. MO equal to F, electric force. F will be AM. And tension will be AO. Right? Now, rearranging it. F upon W. F upon W will be equal to F of W AM over MO. AM will be equal to, this is AM will be perpendicular of hypotenuse sin theta by 2. L sin theta by 2. And in this case, base support hypotenuse, that will be L cos theta by 2, that is tan theta by 2. Right? This is equation 1. Now, as earlier, system was in air, and later suspended in water. Suspended in water. Say liquid. Say liquid. Take as a liquid. In that case, and theta remains same. Theta remains same. Therefore, F air or W air will be equal to F liquid or W liquid. This will be same. We are concluding from this one, right? In that case, F liquid, F air or F liquid will be equal to, is called W air or W liquid. That is M into G over M into G effective. Whenever anything dipped in liquid, weight will be slightly decreased, and that will be the apparent weight according to the Archimedes principle. Now, in that case, to find G effective, according to Archimedes principle, apparent weight M G effective will be equal to weight M into G in air minus upthrust V in density of liquid into G. V means volume of the body inside. As it is dipped completely, so that will be same. Volume of body into density of material of the body, G effective, equal to volume of body into rho m minus Vb rho L into G, density of liquid. Vb goes VB goes into G effect, G air, right? This is G air also. G is also. Therefore, G effective will be 1 by, G effective will be rho m taken from 1 minus rho L upon rho G, rho L upon rho m into G. So G effective comes out to be this one. G effective comes out to be this one. Now substituting this one. F first is F air, then F liquid. F air 1 over 4 pi epsilon naught Q into Q upon, say the separation is x square. Then 1 over 4 pi epsilon naught Q into Q upon x square, separation remains same because angle remains into K, equal to, what is this? F liquid upon W air, M into G air over M into G effective. G effective is G air into 1 minus rho L over rho M, right? This goes, this goes, this goes, this goes, this becomes K. M goes, here goes this. So this on simplification, this comes to rho M over rho M minus rho L. This is the final formula. If you put in the values, this is the final formula. Now, this will be rho M over rho M minus rho L. Density of the material is 1.5, right? 1.5 minus 1, that is comes out to be 1.5 upon 0.5, that is 3. 3 is the answer. I explained the complete question, reason being if slightly twist in the question, then we will fail to answer it, right? Because in the case of JEE Advanced, direct questions possibility is very, very rare. Therefore, this is the direct question answer in this case, right? Similarly, in the first question, answer was very straight and direct one. Now, I would like to request, if you are new to my YouTube channel, City Shift Learns, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.